It all started in the 1940s. After the horror of many because of the atomic bomb used in the war, nuclear energy promised to be a peaceful new technology helping the world get back to its feet. Everybody's imagination was going wild. Would electricity become free due to nuclear energy? Could nuclear energy help us settle in the Atlantic? Would there be nuclear-powered cars? It seemed like this future was just seconds away. But one thing is for sure, our future would be nuclear.
So, what is nuclear power generation?
Nuclear energy is the energy stored in the nucleus, or the center of the atom. Nuclear power plants split these atoms into even smaller atoms, which causes heat to be released. This process is called fission. The energy released from this process is in a form of heat. This heat is used to boil water to make steam. The steam is used to spin giant turbines that work a generator, and the generator is used to help make electricity. After the steam cools down, it turns into water, and this water can be reused again.
The fuel most commonly used for nuclear fission is uranium. However, other elements such as plutonium and thorium can also be used. There is another way to obtain nuclear energy, and it's through a process called fusion. This is the same process that powers our sun. Fusion is a nuclear reaction which atomic nuclei collide at a high speed and join to form a new type of atomic nucleus. During this process, matter is not preserved because some of the matter of the fusing nuclei is transformed into photons, which produce energy. Fusion offers the idea of unlimited amount of energy. However, creating the condition of nuclear fusion is a challenge for scientists today. Now, let's get into the raw materials.
The first picture is a picture of the balanced chemical equation of nuclear fission. What is happening is that uranium is being given energetic particles, and the uranium atom is split and gives off massive amounts of nuclear energy in return. The second picture is the structural diagram of uranium-235 and uranium-238, the two most commonly used uraniums for nuclear fission. This picture shows the chain reaction of nuclear fission and how it gives off energy after giving the atoms energized particles. This picture is an example of uranium. Uranium is a silvery, shiny metal that is both ductile and malleable. Its melting point is about 1000 Celsius and its boiling point is about 4000 degrees Celsius. Also, commonly used in nuclear power generation is thorium and plutonium, which are also very ductile and malleable, and both also have a very high boiling point and melting point.
What are the chemical properties of these elements? Well, uranium is a relatively reactive element. It combines with nonmetals such as oxygen, sulfur, chlorine, fluorine, phosphorus, and bromine. It also dissolves in acids and reacts with water. It forms many compounds that tend to have a yellowish or greenish colors. Thorium is soluble in acids and reacts slowly with oxygen at room temperature. At higher temperatures, it reacts with oxygen more rapidly, forming thorium dioxide. Plutonium is highly reactive and forms a number of different compounds.
Uranium, a common ore found in the Earth's crust, is extracted for use as nuclear fuel in nuclear reactors. Concentrations of uranium are found mainly in North America, Australia, Southern Africa, and Central Asia.
The ore, which contains many other minerals, is mined and transported to the uranium mills, normally on the mine site. Here, the ore is ground into a powder and the uranium is separated and purified to produce a dry powder of uranium oxide known as uranium ore concentrate.
These concentrates, generally known as yellow cake because of their color, are then transported in sealed 210-liter drums in standard sea freight containers to chemical conversion plants.
Nuclear energy has one of the lowest impacts on the environment of any energy source because it does not emit air pollution, isolates its waste from the environment, and requires a relatively small amount of land.
There are countless benefits of using nuclear energy. The lack of carbon emissions, the ability to create huge amounts of energy, and the sustainability of power production are all very important. There are also no fossil fuels used in nuclear energy, hence there are no direct carbon emissions.
Also, indirect carbon emissions are limited into the facility. Adding on, unlike other sources of electricity, nuclear plants do not depend on the conditions around them to function.
So how do people react to nuclear energy? Setting up a nuclear power plant in any region does not come without concerns and criticisms from a variety of people. People in such regions fear the threat of being exposed to unnatural levels of radiation. The natural water sources in such places are also doubted to contain plant emissions, especially if the plant uses the body of water as a heat sink. In addition, during the post-9/11 era, there's also been an increased concern over the reactor itself and integrity. As such, a lot of effort has to go down into convincing people living around the plant that it is securely designed with several safety measures.
Nuclear energy is not what all people think. Nuclear energy, like solar power and wind power, is a low-carbon energy source emitting only 16 grams of CO2 per kilowatt hour. Nuclear energy produces a little volume of waste, which are monitored with great attention. Nuclear energy is a very reliable energy source, generating at all hours of day and night.
So how much does building a nuclear power plant cost? Well, according to a 2009 UCS report, nuclear plant construction is currently $9 billion per unit.
Many countries have the money to make advances in nuclear technology. However, the political concern is that countries such as Iraq, Iran, and North Korea have brought the connection between nuclear energy and nuclear weapons into the international spotlight. As the media coverage grows around these stories, it is important to remember the cold hard facts about these types of nuclear technology each country actually possesses. A problem is that these advances in nuclear technology may be used as a form of weapon by countries and may lead to nuclear war.
Historically, nuclear power plants have two big problems. They produce nuclear waste and they can be vulnerable to disasters such as a nuclear meltdown. A nuclear meltdown is when water that is used to cool the radioactive fuel rods cannot be pumped in. It usually cannot be pumped in due to a backup power failure.
This fuel heats up rapidly, and since the reactors include a very high amount of pressure, there can be explosion from excess heat. Leslie Dowen is an American entrepreneur who is trying to fix this. Her company is trying to create reactors that operate in atmospheric pressure, which allow a lot more flexibility in architecture of nuclear power plants. By having less pressure, there will be a lower chance of nuclear disaster.
Per Peterson is a nuclear engineer. He has produced a product called a fuel pebble, which contains uranium in a golf-sized ball sphere, but is made up of a strong ceramic material which can withstand high temperatures. These fuel pebbles also cannot melt. If there was a power failure to occur, these pebbles would just simply empty out into a tank without causing any failures or any disasters.
So let's think about nuclear energy. Its low-carbon energy source can be used together with solar power and wind power. With an energy mix, nuclear energy is a part of the solution for electricity and climate changes that our planet is facing. To fight climate change, nuclear is part of the solution.